Everyone, today I'm going to be diving into queues. So I'll be telling you everything you need to know about queues in order to get a job or in order to pass your interviews. So let's just get straight into it. What do you need to know about queues essentially? So first off, a queue implements a FIFO or first in, first out ordering. So this is very common in the real world. You deal with um, queues all the time. Like for example, we have a Disney ride. Like I just came from Disneyland, so pretend we have like this roller coaster that does a loop, right? Pretty much, they put humans in a queue in order and make them wait for it, right? So pretend this is one human, another human, right? And then let's just give them different names like A, B, C. So basically, the first person who goes into the queue is the first one out. That means people pretty much enter the queue from here, the back of the queue, and then pretty much the first one who came in is the first one who's gonna ride the roller coaster, right? If the roller coaster is like takes in one person at a time only. So it's very common in the real world. Let's see. What else? Yeah, pretty much as in real life, items are removed from the data structure in the same order that they are added. So pretend um, someone someone goes on the roller coaster, but then pretend in the back a bunch of people just like come in. And then we'll remove these. A B C D E. These are people joining, and people can keep joining as they want. But pretty much, as soon as we process this guy, this next person is allowed to go, right? So we're processing them pretty much in the order where they come in. That's a queue, and it's really useful in algorithm questions as well. Like if you're traversing a tree and you want to if you're traversing a tree and you want to do breadth first search, like traverse the tree like breadth first search, you typically use a queue. So pretty much the main operations are adding someone to the queue. So when you add someone, like I mentioned, they usually come in from the back or the start of the queue. And then when you remove, that's also called end queue. So yeah, that adds an item to the end of the queue. And then when you remove somebody, you remove them from the front of the queue, right? So when you do remove, it should remove this guy who's at the front of the queue because that person is next, and move them out of the queue so there's somebody new at the front who can go next. So yeah, peak pretty much tells you who is in the front of the queue. So in this case, peak will return you A. So person A is in the front of the queue. Is empty and size is something that you implement in a lot of different data structures like stacks as well. And pretty much is empty just tells you true if the array is empty, false otherwise. And then size gets the length of the queue. So here the size 1, 2, 3, 4, 5. The size here is equal to 5. And typically arrays are implemented using linked list. Arrays are implemented using linked list and not arrays. Right. Let me move this around. Yeah. Oh, sorry. Queues are implemented using linked lists and not arrays. And that's because if we use an array, it's because when we do this remove operation, we're removing from the front of the queue, right? So pretend we have an array of like A, B, C, D. In my arrays video, I showed that like pretty much the only time, like if you remove something from the front of the array, it leads to an O of n time complexity. So pretty much if I remove A here, that leads to O of n because I have to shift all the elements over, like all the elements in the queue over by one to finally build this array like this. And then this would probably be like another or sorry, it would be like this. Since we're moving it over, we put B, C, D, and then there's a D here, but then we just remove that. That's kind of how you remove from the front of array, but that's O of n operation. That's why typically we implement arrays using a linked list, usually a doubly linked list. So let's say we have a linked list like this, right? And then we're given O of we're given A, B, C. You're given the head and tail here. So now I'm using linked lists and not arrays. Since it's a linked list, if when we want to remove the element here from the front, we essentially do this. We set our head equal to this one, and then we can get rid of these pointers and return back this element, right? And you can see that we don't need to shift elements over, like all the elements to right over. We just leave them as is, and that leads us to like a O of one time complexity. So that's why queues use linked lists and not arrays. But if you saw my last video on stacks, everything you know, stacks can be implemented with arrays or linked lists. But yeah, cool. Let's just go with that. I think I kind of already gave the example there of how a queue works. So let's just make sure to reiterate it right here. I'm just gonna put it down here, right? And I'm gonna talk about all these different operations right here. I'll talk about the main operations, which is add, remove, peek, is empty, and size, right? Move this up a little. Okay, pretend that we just have an empty queue. Move these people here. Pretend we have an empty queue. The queue, we'll look at the queue like linked list, like a linked list essentially. So let's just add an item to the queue, right? So add an item to the queue. In that queue, or that person typically has a name, and they go to like the back of the queue. Essentially, like they'll be at the start of the line, right? Then if somebody else comes in, like if we keep adding, so pretend we do this. Let's just write the code that we want there. So say queue equals queue. We'll initialize it in pseudocode. Queue dot. Let's add like a. Then we'll go. Then we'll add person B and person C, and then we can remove people. So we can remove, and then we can also peek who's at the front of the queue, and then finally we can do things like is empty and size is kind of self-explanatory. So I'll just go with add and remove and peek for now. So we add person A, right? And then we add person B here. A, B, and then now we add person C, line this up. So add person A, B, C. When we call remove, pretend this is our queue data structure implemented as a linked list. So it's kind of like this. If it's a doubly linked list, when we remove the first person from the queue, all we essentially need to do is When we call remove, we get person A. So that kind of moves this guy out of the queue. Cancel him. And now this person's at the front of the queue, B. So if we do a peek, we get B, right? And like when we peek, we don't pop the element out, right? We just get B, but we don't move them out of the array. We kind of just like look at who the top of the array is. Then finally, like if we want to like remove them, remove. Sorry, there's a bit weird. So peek, it would return B. And when you remove, since it's first in, first out, the next person to process B. So that returns B as well, but it actually moves them out of the queue. And now our queue is pretty much this one last guy. So that's how a queue works. It has these operations: add, remove, and peek. And then these are common functions between all the other ones, including stacks, is like is empty and size. And yeah, pretty much all, like one of the things that I'll just hammer on is that usually we implement queues using linked lists, a doubly linked list to be specific, and not using an array. Because if you use an array, then you have to move elements over to the left, and that causes the runtime to be O of n. Essentially, you want to do all of these in O of 1. You want to add items O of 1. You want to remove items O of 1. You want to peek the front of the queue in O of 1. You want to check if it's empty in O of 1. And you want to check the size O of 1. And the only way to do that is with a linked list and not a queue. Because, yeah, I mentioned that a few times already. And cool, yeah, very common in the real world. Remember, first in, first out ordering. And yeah, that's everything you kind of need to know for queues. Like, don't go too deep into it. Just know how to use a queue, when to use a queue. Usually it's typical for BFS or breadth first search. And yeah, thank you. I'll see you in the next video.